This is an example of using Hess's law to find the heat of reaction with compounds and not using other given equations. So we have an equation here that's balanced, really important. These coefficients are going to be used later on. And we have our Hess's law calculation, the formula for that. It's the sum of the heat of formation of all the products minus the sum of the heat of formation of all the reactants. Now I need the heat of formation values for the reactants, which are on the left hand side, and the products, which are on the right hand side. I need those numbers. So you'll have to look up in a table or in the back of your book, or you may be given this in the question itself, but those numbers are going to be in some sort of form of a table like this. And so I had methane, that was a reactant, and here are the values in kilojoules per mole. Carbon dioxide was a product, negative 393.5, and water, be sure that you're checking what form of water is produced. This is liquid water or gas water. So our equation involves the liquid form of water, so negative 285.8 kilojoules per mole. We're going to put those values in here on the left for the methane and for the carbon dioxide and water. Now this is where the coefficients are important. We multiply the heat of formation by the coefficients from the balanced equation. And just as an aside, to remember that the heat of formation of any element is 0 kilojoules. So we need the sum of the products and the sum of the reactants. So the reactants is just the heat of formation of the methane, which is negative 74.87. And then if we do the math on the right hand side, we got the sum of the products being negative 965.1 kilojoules. And so now we can put it into the equation. The products minus the reactants, so the sum of the products minus the sum of reactants, and you would get the heat of reaction as negative 890.2 kilojoules.